Alright, Math 3, Practice 2A.4.1, Solving Systems of Equations Graphically. So we're just taking a look at these and seeing what we can understand about where they are the same. So when we're solving a systems, we just want to know where two or more graphs intersect. Now we're dealing with different kinds of graphs than we did in Math 1 when it was just two linears. So if we look at question 1, okay, 1 through 3 just wants us to look at the graph and estimate where they are. So where did they cross? Looks like we got one here, here, and up here. Okay, so what are those solutions? Would be 6, 0, 2, 0, and then estimating this one on the left, probably like negative 1.2. and then going up about 18.2, something similar to that. And that's all there is to it. Not too hard, right? Alright, question 2. Okay, now notice it's a flat line, so we know that all the y values, it looks like there's 5 solutions, doesn't it? All the y values are going to be 6, because it's a flat line at 6. So what are our x's? Well, we've got negative 3, negative 2, negative 1, then 1 and 2. So that's it. That one wasn't too difficult, was it? Okay, now 3. Okay, so we've got 3 points here again, so a cubic and an exponential. So this one's pretty close to negative 3, 4, so we'll just call it negative 3, 4. Then this one would be about 0.5 or 1/2, and the y value a little more than that, so let's actually make that a decimal, 0.5, and then it would be like 5.3 maybe, because they're counting by 2's, and the last one would be probably like the y value 9.6 maybe, and the x would be about 2.5. Okay. Like I said, those are just estimates. Normally we'd have the equations and we'd graph them on the calculator, which these next problems want us to actually graph them on the calculator. So I'll kind of go through that really quick. Is how we do it. You could use Desmos at home. Just type them in and find where they intersect and put those down. I'll be doing it on the calculator though. Alright, so let's talk you through how we do it on the graph. So first off, when you first open up the graph, you can either go to graph right here on B on the scratch pad, or you can hit new document. I prefer new document. Once you hit new document, you go down to add graph, and if you just hit graph, it would take you to this. Okay, now it usually gives you the way you can write it in. Now look, it's in function notation, so if your equations aren't in function notation, you have to do something else, which I can show you at another time. Okay, but then you type in your equation. If it doesn't pop up, you can go to menu and graph entry edit number 3, or you can just hit Control and G for graph and that'll pop it up. So if you ever lose it, Control G is an easy way to get it back. Okay, then you just type in your equation as it sees without the f of x because you've already got it. Then you can hit enter, but then you'd have to hit Control G, so I usually just press down. And that'll take me to, it'll say f2 of x. And then I type in my second equation, then I hit enter, and as you can see, I've got my two equations, different colors. Now, I'm not sure if it intersects just at this place, so sometimes you may need to zoom out. So if you hit menu here, go down to window zoom, you have many options. Okay, you can hit zoom out if you just want to check, or you can try to change the window settings to give you a better view of the graph. Okay, so when you hit zoom out, then you can do this. Okay, so I zoomed out, and now I can see it only crosses in one place. Okay, if it crosses in more places, you just do the next steps more than once. So you hit menu again, then go down to analyze graph, and you can see it's got one for intersection. So you click on that. Then using the touchpad, you've got this line. You go to the left of it for your lower bound, then you click. Then as you go to the right, you'll see this shaded area, and usually it pops up right then. One of them does. Then click enter again, and it'll give you your answer, which for us is 2.18 and 2.46. That's the one solution. That's where they intersect. And that's all you have to do with that. Okay? So you can just use that for any of those problems. Or you could use Desmos as well. Okay? And I'll use Desmos for the rest just for sake of time. So remember, Desmos, you can go to the website, desmos.com, or download it on your device. And then you just go in and you type the equations as you see them, and then you find where they intersect. So for number 5, and that's all you're doing on these, is you're using technology to graph it and also to find where they intersect. So if we look at number 5, the absolute value one is the red, the polynomial is the blue. The only place where they intersect, two of them, -1, 6, and 3, 6. Okay? And that's all you end up having to do. Not too bad, right? So, let's do the last two. You just type them into any graphing device and get your answers. Alright, so this is number 6. Now, sometimes you have to manipulate your window to make sure you spot all the times where it's going to intersect. Okay? So, we've got 2.31 and 24. You could round that to 0.6, that's fine. Same with this one, you could round to 0.6 and 2.18. Okay, not too bad, right? So now the last one, we take a look at this one, and it just seems to cross once. So we get 0.444 and 6.56. Okay? And that's all you got to do when you're given a system and you've got a graphing functionality using the calculators we have or Desmos. Either one works. Alright, now looking at 8 through 10, we're dealing with tables that are systems. Okay? Now the problem with tables is they don't always tell us exactly what's going on. Okay? So that's where we're going to run into issues. But what you should notice is this is lower, higher, lower, higher, lower, higher, lower, higher, lower, higher. Now they're the same. And they're the same. Then this one's higher and this one's lower. That stays higher, stays lower. You're basically looking at points where they would either touch like this. You can see that 0, or not 2, 0, because the x value is 2. 2, 0 and 3, 0, they intersect. Okay, but sometimes they may intersect in between points. So that's why you've kind of got to pay attention. So let's take a look at 9 and see if it does that. So notice this one's lower than g of x. F of x is lower, still lower. Now they're the same. Now this one's lower, 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 lower. So there's only one point where this one does it. So 2, 2. Okay. Alright. Oh, not 2, 2, 0, 2. Duh. I keep forgetting the x's. Not used to seeing tables like this. Alright, so now let's take a look at the next one. Okay, so this one's lower, 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 lower. Okay. Still lower. Now it's higher. Okay. So that's an important part, even though they're not the same right there. Okay, then this one's lower, lower, and lower. So somewhere between 0 and 1, it's going to cross. Where exactly, I don't know. Okay, I don't know. So I wouldn't be able to do it just off of this, but I know between x equals 0 and x equals 1 that they're going to cross. So that's all I would be able to write here. Anyway, there we go, guys.